All right, good afternoon, everyone, and welcome back to our virtual science classroom. And today, we are going to continue our topic, which is all about the periodic table. And as we all know, periodic table that we have now is the modern design, which was developed by Mendeleev and other scientists that we have tackled last time. So for today, our focus is mainly on their periods and groups. The periodic table of elements is mainly composed of these two important things that can be found in the periodic table of elements. We have the groups and the periods. Groups or families are the 18 columns in the periodic table, while periods are the 7 horizontal rows in the periodic table. So we are going to differentiate these periods and groups or families. In period 1, this contains two elements having atomic numbers 1 and 2. The elements with atomic number 1 lies in the group 1A of the S block, and that with an atomic number of 2 is in group of P block, which is all we know that the number 1 is hydrogen and the number 2 is helium. This period is also known as the short period. Period 2, this contains 8 elements with atomic number of 3 to 10. The elements with atomic number of 3 and 4 lie in group 1A and 2A of S block, and those with atomic number 5 to 10 is in groups 3A to 0 in P block. Okay, those 0 group are the noble gases. Alright? And in period 3, this contains 8 elements again with atomic number of 11 to 8, and the elements with 11 and 12 atomic number lies in group 1A and group 2A of S block, while 13 to 18 atomic number are included in group 3A in P block. Fourth period contains 18 elements with the atomic number or Z range from 19 to 36. The elements with 1920 atomic number lie in the S block, while 21 to 30 is in B block, and 31 to 36 in P block. This is known as the long period. And as we go on to period number 5, it contains 18 elements as well, with the range of atomic number from 37 to 54. The elements with 37 and 38 atomic number lie in the S block, and 39 to 48 lies in the D block, and 49 to 54 in P block. And this is known as well as the long period. And when we go on to period number 6, it has 32 elements, ranging from atomic number of 55 to 86. The elements with 55 and 56 lie in the S block, while 57 and 72 to 80 in D block, 58 to 71 in F block, and 81 to 86 in P block. This is known as a very long period because in this period, F block is already included. And on the period 7, this contains remaining elements ranging the atomic number from 87 to 105. The elements with 87, 88 lie in the S block, 89, 104, and 105 lie in the D block, while 90 to 103 is in F block. This period is still incomplete. That is why there are a lot of spaces or blank squares in the periodic table. Now, let's proceed to groups or families. They are included in these groups or what we call families because they share the same characteristics or properties. And let's start with group 1A, because group or families is divided into group A and then group B. So let's start with group 1A. Group 1A is known as the alkali metals. Alkali metals have one valence electron. They are soft metallic solids with characteristic of metal properties like shiny luster and high thermal and electrical conductivities. The alkali metals have low densities and melting points, increasing and decreasing respectively with increasing atomic mass. While group 2A, these are called the alkaline earth metals. The alkaline earth metals have two valence electrons because they are included in group 2A. They have characteristic metal properties but are harder, more dense, and melt at higher temperatures than the alkali metals. Their reaction with water increases down the group. So beryllium does not react with water even when heated red hot. Magnesium does not react with liquid water but does react with steam. Calcium and the elements below it react with water at room temperature, although more slowly than the alkali metal adjacent to them on the periodic table. For example, magnesium and calcium are essential for living organisms. Like mostly 99% of calciums can be found in the skeletal system of a human body. And in group 3A, these are called the boron group. The boron group has 3 valence electrons, and the most common or well-known element here is the aluminum, which we are all familiar and very useful in our houses or in the industry. And it is found in nature as a bauxite, which is the Al2O3. Okay, so it just need to be processed for you to be able to get the aluminum in that bauxite. And then we have group 4A. These are called the carbon group. So members of this group have 4 valence electrons. Carbon is unique among the elements because it's the ability to combine with itself and other elements to form an almost limitless number of compounds. So when we are talking about organic substances, carbon is included. Carbon is found in nature in the form of coal and diamonds. The chemical difference between them is their crystalline structure or the lattice structure. All right? So which gives them the different physical properties. As we all know, diamonds is the hardest of all known substances. No one can break a diamond unless it's a diamond. And then we have group 5A. Group 5A are the nitrogen group. Members of this group have 5 valence electrons. Nitrogen makes up about 80% of the air at normal temperatures and atmospheric pressures. Molecular nitrogen is almost inert. Commercial production of nitric acid or nitric acid is accomplished using the Ostwald process. Nitric acid is also used in the manufacture of drugs, dyes, plastics, and explosives. So, nitroglycerin and trinitrotoluene or TNT are 2 commercial explosives that we are familiar with. And as we go on to group 6A, these are the members of the oxygen group or the chalcogens. Okay, so they have 6 valence electrons. There is a change from non-metallic to metallic character as we move on down to this group. Like oxygen, sulfur, selenium are typical nonmetals. While on the other hand, we have tellurium or tellurium has some metallic properties and it's classified as metalloids because metalloids have both characteristics of being a metal and a non-metal. And polonium, which is also included in this group, is radioactive and quite rare, which is also a metal. And in group 7, these are called halogens. Halogens have 7 valence electrons, and they are typical nonmetals. Their melting and boiling points increase with increasing atomic number. Fluorine and chlorine are gases at room temperature. Bromine is a liquid, and iodine is a solid. Halogens are highly active with high electron affinities because in their outer shell level, their valence electron is 7. So they need only 1 for them to become stable. So they are highly affinity or electron affinity because they only need 1. It's like they are the most handsome and they are the most beautiful faces that can attract a lot of electrons. Alright? And of course, in fact, the letter X is sometimes used in chemical equations to indicate any of the halogens elements. Chlorine gas is so reactive that it is difficult and dangerous to use, requiring specialized lab equipment like fluorine. Chlorine reacts slowly with water to form relatively stable aqueous solution. Chlorine is often added to drinking water and swimming pool. Of course, this is for disinfectant. Halides are very soluble in water and dissolve to form hydrohalic acids. And of course, group 8A is the last group in the periodic table, which is located at your far right. And they are called the noble gases. The noble gases have 8 valence electrons. Because the noble gases possess such stable electron configurations, they do not need anything. Their outer shell level is already completed, meaning to say all the electrons has their own partners. They are exceptionally unreactive. In fact, until the early 1960s, the elements were called inert gases because they were thought to be incapable of forming chemical compounds. But now, xenon is now known to react with fluorine gas to form the molecular compounds such as xenon and then F or fluorine 2, and then xenon, fluorine 4, then xenon, fluorine 6, or the XeF2, XeF4, XeF6. And then the only stable compound of krypton is known as krypton fluoride or KrF2. Alright, and those are the different group names or family names in the group A. Okay, let's go to group B or the transition metals. All the D and F blocks are all metals. They have 2 valence electrons. Since they are large atoms, they have that shielding effect that causes them to have wide range of possible oxidation numbers, so they can interchange from time to time because of that shielding effect. So this oxidation number can change when forming compounds. And as we all know, periodic table of elements is subdivided into 3 categories. We have metals, nonmetals, and metalloids. So here in our periodic table, the blue highlighted elements are all metals. The green one, which is like a line that separated the metal and nonmetals, are the green part that is located at the right side, mostly on the P block section. All right. While nonmetals are all located on this side, except for hydrogen on your left side. Okay. So mostly these are group number 4, 5, 6, 7, and 8. Okay, so let's talk about nonmetals, metals, and metalloids. Metals in the periodic table are the alkali metals, which is the group 1A, the alkaline earth metals, the group 2A, transition metals that includes inner transition metals in group B, and heavier elements in group 3, 4, 5, and halogens. So nonmetals, those are the elements located above and to the right of the periodic table, while metalloids possesses both characteristics of and intermediate between metal and nonmetal. It touches the metal and nonmetal line in the periodic table that I've shown you a while ago. So the most common metalloids are silicon and germanium. They are commonly used as semiconductors that can be used as well in the manufacture integrated circuits and computer chips. And of course, we have these noble gases that can be found in our periodic table. These are the elements under group 8A, known for their inertness and stability. The representative elements under the B subgroup, also known as the D block transition metals. But take note, group 2B elements are often classified as transition metals, even though they do not exhibit transitional metal characteristics. And we have the transition elements. Those are the elements in the D blocks of the periodic table. Then we have the inner transition elements. These elements are found at the bottom of the periodic table, but they belong to the 6th and 7th periods, also known as the F block. So the F block transition metals are named as the lanthanide and the actinide series. Okay? And for your written work number 4, do not forget to identify and take a picture of 5 common metals, 3 nonmetals, and 2 metalloids found at home. So what you're going to do is to take a picture of it, name, and then write its uses. Again, take a picture, write the name, and write its uses as well. Okay, so these are the common metals, nonmetals, and metalloids found at home. 5 for metals, 3 for nonmetals, and 2 for metalloids. And for your performance task, number 4, make infographics about the atomic models and the periodic table timeline. So you're going to make 2 infographics. The other one is the first topic that we had, the atomic models or the atomic structures. And then the second one is the periodic table timeline. So I do hope you learned something today, and see you next time. Have a nice day and God bless you all.